When we try to understand current electricity, we will come across a term drift velocity. Now let us try to understand what is drift velocity. In a conductor, there are a large number of free electrons. Atoms, after losing electrons, there will be positive ions in a conductor. Under ordinary temperature, this electrons will be at a random motion. So that is zigzag motion. So that will not make current. On an average, for each number of electrons moving in a particular direction, there will be equal number of electrons moving in an opposite direction. So net current will be 0. Suppose you maintain a potential difference across the conductor by connecting a battery. This is a positive, this is a negative. So there is an electric field in this direction. Electrons are attracted by this positive terminal, so electrons will be moving that side. Under the influence of the electric field, electrons will acquire a velocity, that is drift velocity. Drift velocity is the average velocity acquired by the electrons under the influence of electric field. This electrons are experiencing a force. Because of that, there will be an acceleration. But that acceleration can act only for a short interval tau. Before that, it will collide with other atoms or other ions or electrons. So acceleration can act only for a short interval tau. This is a Greek letter tau. According to Newton, force is mass into acceleration. So acceleration is force divided by mass. Here force is minus E. E is the electric field intensity. Electric field intensity is the force per unit charge. Charge on the electron is E. Then charge on the electron is negative. So force is minus E by m. That is the expression for acceleration. Acceleration is force divided by mass. Then drift velocity is a tau. A is the acceleration rate of change of velocity. Then acceleration is acting only for a short interval tau. So a tau. This is the rate of change of velocity. Change in velocity in 1 second. So acceleration is acting only for a short interval tau. So drift velocity is a tau. Then for this acceleration, you can substitute this minus E by m tau. Then E you write separately. Then E tau by m. You can substitute mu. Mu is E tau by m. E you write separately. Then E tau by m, you can substitute mu. So drift velocity is equal to minus mu E. Mu is E tau by m. Mu is called mobility. Mobility is the drift velocity acquired per unit electric field. You can rearrange this, and mu can be written as Vd by E. Then take the modulus. So because this, when you take the modulus, this negative sign is not needed. So mobility is defined as the drift velocity acquired per unit electric field. So in this video, we have come across two important terms. Mobility, the other one is drift velocity. Drift velocity is the average velocity acquired by the electrons under the influence of the electric field. Mobility is the drift velocity acquired per unit electric field. Velocity is measured in meter per second. Then intensity is measured in volt per meter. So this can be taken up. So it will be meter square divided by second, then volt. So it can be written like this: meter square second raised to minus 1 volt V raised to volt minus 1. Across a copper wire, a potential difference is maintained by a battery. So there is an electric field. Under the influence of the electric field, electrons are accelerated. We have to find the acceleration when the electric field is 517 Newton per Coulomb. According to Newton, force is mass into acceleration. Force experienced by the electron is given by this expression E. Capital E is the electric field intensity. Electric field intensity is the force per unit charge. Then charge on the electron is E. So F is equal to E. Then acceleration is force divided by mass. Force, we can write the expression E. Then charge of an electron is 1.6 into 10 raised to minus 19. Electric field intensity is 570. Mass of the electron is 9.11 into 10 raised to minus 31. These two values are very important, so you have to remember to do this problem. Now calculation can be made simple. So now 570, move the decimal point 1 digit to that side, so power will become minus 20. Here you move 2 digits that side, decimal point is moved 2 digits that side. Then here the power minus 31 will become minus 33. Then minus 33, when it's taken up, it will become plus 33, so 10 raised to 33. Then when you multiply these two numbers, 9120, that is to be divided by 911. So when you divide, you will get this number 10.01. When we combine these two powers, it is 10 raised to 13. Then to make it in the scientific notation, move the decimal point 1 digit this side, so the power 13 will become 14. So acceleration experienced by the electron is 1.001 into 10 raised to 14 meter per second square. Now I would like to talk about a misconception. It is a misconception that battery is a source of electrons. Battery is not a source of electrons. It is providing the energy to the electrons to flow in a circuit. Usually we say, in my mobile there is no charge, or battery of the mobile is to be charged. When we say that battery of the mobile is to be charged, we are providing energy to the battery or potential difference so that electrons can flow. We are not providing electrons. When we connect the battery to the AC source, it is providing energy to the battery, not electrons. Thank you for watching.